For the project, as you are going into your physical architecture and you're starting to build out what your system is going to look like, it is actually relatively useful to use ChatGPT. It is a great reference for doing this type of analysis. Again, it's a good idea to check everything that it tells you, verify all the information that it has, ask it for references. But let's just walk through a quick example. So suppose one of my physical architectures for this is I'm going to use a vibration sensor to pick out every time that my rifle fires around and just assume the magazine is full at the beginning and just keep a track of how many shots are fired on that magazine. This is probably a pretty poor way to do it. And there's better ways, such as just measuring the position of the lifting platform, which would be my recommendation. And there's a lot of different ways you can measure the position of the lifting platform. But for this example, let's just roll with that vibration-based sensor, looking at the magazine shaking from the vibration. It's important to enter the right prompt into ChatGPT so it gives you something useful and relevant. So here's the prompt I used, and I went ahead and run this just so I can make sure that everything runs smoothly. I did run it a few times. A couple of times I got issues with ChatGPT's ethics sensor about weapon design, so you have to be a little bit careful and massage what you ask to do that. So I wrote, I am designing a small self-contained module that will mount to the side of a standard 5.56 M4 magazine containing 30 rounds. The module will pick up the vibrations associated with a bullet firing to identify when the magazine dispenses a bullet. It keeps track of the number of rounds fired to determine the number of rounds left in the magazine. The count is transmitted to an ATAC device. The system is intended to be small to optimize size, weight, and power. Can you provide me a component list of the items that I would need to build this? So you can see right here, it then starts telling me what I'm looking at, which is fair. It's a rugged, ultra-low power sensing, edge processing radio system in a very constrained form factor. So it breaks everything up. We have our sensing with using a MEMS accelerometer. It recommends a few different types. The processing portion, the communication, power. And you might see that this aligns actually very well with what your physical architecture would likely be. You have your memory, and then you have your mechanical and integration components that go with it, as well as your firmware. And right here you can see your minimum BOM. And it's useful at this point to actually Google all of these to make sure they actually exist. So let's go with our accelerometer. And you can see that that is a Adafruit, it's an Analog Devices accelerometer. It's 3-axis, and it basically provides the specs on the sheet match what we saw on here. So you can see some engineering challenges because it's being fair. So the next thing I asked it, just because I care about size, weight, and power, and the next step I want to do is start modifying a weapon magazine to allow for this, is I want to provide the approximate dimensions that the system would be so I can mount it to the side of the magazine. So I asked for that, and you can see down here that it starts providing me values. So physical constraints for the magazine, as well as a realistic module size, and that's being driven a lot by the battery, the PCB, the enclosure and mounting. And so it's telling me that if I want to be ultra compact, it'd be 40 by 18 by 6 millimeters. But a practical recommendation is I go 50 by 22 by 8. So the next thing that we're going to do is we're going to modify our magazine so that we can have it accept this vibration sensor, so that can be built into the magazine. All right, so I'm going to mount it to the side here. More than likely, you're going to be doing something that is associated with determining the distance between the bottom of the magazine and the lifting platform. So you're more likely to modify the bottom of the magazine instead of the side. But for this example, I'm going to modify the side. So I'm going to start by drawing on this surface right here. And again, this is a 3D scanned image of a magazine that I found online. And we are just going to do some modifications to it. It saves you from having to draw an entire magazine. So I'm going to draw on this surface right here and mount my new module to it. So I'm going to click on that surface, hit sketch, and the first thing I'm going to do is I'm going to draw a rectangle. I know that it's 50 by 22 by 8 millimeters. So let's go ahead and measure this out. Here's Smart Dimensions. So this should be 22 millimeters. This should be 50 millimeters. It's going to be 8 inches deep. Next thing I'm going to do is I'm going to position this. So I'm going to go ahead and say this should be approximately, let's do 0.2 inches from the top there. And let's go ahead and say that from kind of that corner, right there. So let's say that's 0.4 inches from side. Everything's, that's square is black now, so it's well defined. Since I'm mounting this into the magazine well, or into the side of the magazine, what I can do next is I can do a extruded cut. And I'm just going to go to up to next. So this should cut a hole in my magazine. So I'll hit enter. And you can see I can now see the inside of my magazine. If I look at the top, I can see that hole as well. All right. So the next thing I'm going to do is I'm going to measure out the size of that. Let's just measure that real quick. That's 0.07 inches, so well below the 8 millimeters that I need it to be. So what I'm going to want to do is I'm going to want to, so we know that's 0.07 inches. So next thing I'm going to do is I'm going to click on the surface again, sketch, and I'm going to basically draw a rectangle overlapping with the overlapping with what I drew earlier. And now I'm going to do an extrusion. Extruded boss and base. One dimension, we just saw that was 0.07 inches. So we can see that that now aligns with the back of the magazine. The next thing I'm going to do is, I know it's, let's open a calculator. So 8 millimeters is divided by 20.5.4, it's 0.31 inches. And then so minus 0.07 is going to give me 0.2449 or 0.2449. So let's do 0.245. So we'll set that for the other direction. And that will give me the 8 millimeters I need. And we now have our modified magazine that has a slightly unsightly bump on the side of it to hold all of the stuff we need for our device. I wanted to make it look a little nicer. I can also add in some fillets so it's not quite as rough. So I'll just click on each of these surfaces. Set to be, let's do full preview. That should be fine. Let's set it to be a little bit lower. So now it's a little more rounded. But we have a nice little pack that goes on the side that measures the vibrations. This is not a recommended approach. I just wanted to show you all an example of how you could use ChatGPT to get a list of components you can use, as well as sizing it out, and then modifying the magazine file, which will be made available to you to allow for your additional items to make it a smart mag.